Okay, so let's look at example 5. We're going to take these examples up a little bit of a notch. So if we wanted to solve this basic algebraic equation, we have variables on both sides. Once again, we want to solve for x. Review the goals of solving equations. You want to get your variable terms on one side and your constants on the other. So how am I going to move my variable term by 5x? I hope we all agree I would subtract by 5x on both sides. Doing that allows me to cancel at least out, right? There's 0 pairs. So then I would do 3x minus 5x, and that's negative 2x equals 8. Remember, I want to get x by itself. How do I get rid of multiplying by negative 2? Divide both sides by negative 2, and I'm left with x equals negative 4. A pretty basic variable on both sides equation. We're going to use that to look at how to solve a literal equation in a similar manner. So for this one, we have ax equals bx plus c. Notice the similarities between these two examples. Once again, we want to get x all by itself. So to get x by itself means I'll need to get my x terms on one side. So let's move this bx term. How do I move the whole thing over? To move it all over, I would have to subtract by bx. Because now here, these would be 0 pairs. I would be left with c. And over here, I would be left with ax minus bx equals c. Okay, so now my x terms all are on one side. But we want to get the x by itself. So what we're going to do is we are going to factor out the x on the left side. So remember, factoring is the opposite of distributing. So if I factor out the x, I take out the x, and what am I left with? A minus b. Notice that these two lines are the exact same thing. It just looks slightly different. But if I were to use the distributive property, I would get right back to ax minus bx. The reason we factored the x out is because I wanted to get the x by itself. And now I have the x by itself. So how do I get rid of multiplying by a minus b? Because remember, I need the x all by itself on this side of the equation. Well, the opposite of multiplying by anything is dividing. So I'm going to divide both sides by a minus b. Remember, if I do that, these two on this side, right, a minus b divided by a minus b is 1. So that gives me the x all by itself. And then I'm left with x equals c all over a minus b. Once again, it's a literal equation, so it's going to look a little different than what we're used to because we have all variables. Let's just review what we did. We wanted to get the x by itself. So I got the x terms all on one side. So here I have my x terms on one side, which is great. But now I wanted to factor the x out. So to factor the x out, I did the opposite of the distributive property. Then to get this x all by itself, I had to get rid of multiplying by a minus b. So I divided both sides by a minus b. Okay, let's look at the next one. Example 6. We have, once again, we're going to get x all by itself. If you look at our equation, we have x on the left and x on the right. We want to get them all on one side, okay? It's up to you which x term you want to move, but for whatever reason, I'm going to move the sx term. So how am I going to move this from the from the right side to the left side? I hope you agree, I am going to subtract. because by subtracting, I have a 0 pair there. I'm left with a minus k here. And on my left side, I have Rx minus Sx plus H equals negative k. Okay, so I have my x terms here, but I need to move this plus H because it's not an x term. How do I get rid of plus H? I hope you agree, I'm going to minus H from both sides. Once again, I've created a 0 pair by doing that. So I now have Rx minus Sx equals negative k minus H. Okay, so now my x terms are all on one side, but I now want to get that x by itself. So how can I get the x by itself? I'm going to factor out the x. So I will be left with x in parentheses r minus s. Okay, now once again, how do I get this x all by itself? I have to get rid of multiplying by the parentheses. So I'm going to divide both sides by whatever's in the parentheses. These guys become a 1, so the x is by itself. And then on the other side, I'm left with x equals negative k minus h all over r minus s. One more example. Let's look at example 7. Example 7 is asking me to solve for p. Now, if you notice, I already have the p terms on one side of the equation, which is awesome. But if you also notice, I now want to get the p by itself. Since both terms on this side contain the p, I am going to factor out a p from the left side. So if I factor out the p, I would be left with 1 plus RT, because p times 1 would be p, and p times RT would be PRT. So I just factored out the p. And from this point, the p is by itself. How do I get rid of multiplying by 1 plus RT? I'm going to divide both sides, and I will be left with p equals I all over 1 plus RT. I know these little equations are not the easiest topic in the world because it looks quite different than what we're used to, but this is a fairly common question on the region, so it's something that we need to get practice with. So I want you guys to do the practice problems, and you can check them with the answer key, and also try to do your homework, okay? If we need more time to talk about literal equations next class, we definitely could spend some time just making sure everyone's on the same page. Also, please make sure to do your Delta Math. I'm going to extend the due date for Delta Math. Instead of it being due Friday at 8 a.m., I'm going to have it due Monday at 8 a.m. So if you have any questions, you can ask me in class on Friday.